This is the first video of Module 6, Categorical Data Analysis. Categorical data analysis is for where the response variable is qualitative or categories, such as ordered age group or eye color categories. On analysis of ANOVA, analysis of variance, ANOVA is used to determine how a continuous response variable varies for categorical explanatory variable levels. In contrast, categorical data analysis involves the categorical response variable. In this module, we'll talk about one sample binary categorical data, and then two sample binary categorical data, and in more general case, more than one sample multiple categories data. So this is the Paul the octopus. Paul the octopus was a common octopus who predicted the results of international association football matches. Accurate predictions in the 2010 World Cup brought him worldwide attention as an animal oracle. Paul's keeper would present him with the two food-containing boxes decorated with the flags of the team in the upcoming match. Whichever box Paul ate from first was considered his prediction for which team would win the match. His keeper at Germany mainly tasked him with predicting the outcome of international matches in which the German team was playing. Paul correctly chose the winning team in 4 of Germany's 6 Euro 2008 matches and all 7 of their matches in the 2010 World Cup. He also correctly chose Spain as the winner of the 2010 FIFA World Cup final. In all, Paul amazed an overall record of 12 correct prediction out of 14, a success rate of approximately 85.7%. So our data is pretty simple that Paul the octopus predicted 12 corrected out of 14 soccer game. The question is how usual or unusual would 85.7% success rate be if Paul was just randomly guessing with a half and half chance to choose each country in the soccer game? More dramatically, is this success probability is so unusual, we can say Paul has the psychic power. We can put this question in more statistical form using confidence interval for the success probability in part A and hypothesis test in part B. Confidence interval provides estimates of true population proportion of Paul's success rate. Hypothesis test can tell us how unusual or usual to have 85.7% success rate if Paul was just randomly guessing. In this slide, we will bring a little bit of theoretical concept that we learned in mostly in intro stat course. First, we'll call n as a sample size and x as a number of successful events. Here, x is the number that Paul correctly identified the winning team. P is the true proportion of each event. Here it is the proportion that Paul correctly identified the winner for each game. The point estimate for P is denoted as P hat and can calculate it as x divided by n, number of success divided by whole number, total number. Recall that the number of success x follows binomial distribution when the same event repeatedly happen n times, and each independent event has outcome, a dichotomous outcome. Here, Paul is guessing the winner 14 times or dinner And for each trial, and the success rate would stay exactly the same as 0.5, assuming he is randomly guessing the winning team. So X follows binomial with N and P. Here, the binomial distribution, binomial random variable X with the large sample size, or NP and the N times N minus P, both larger than 15. With that condition, approximately, your X approximately follows normal distribution with the mean N times P and standard deviation of square root of N times P times Q, which is 1 minus P. Q is 1 minus P. From then, the P hat, which is X, divided by N, and N is just constant. So it doesn't really change the distribution. What you just need to do is divide all these items by N. That's what a constant does, theoretically. So from here, P hat, which is X divided by the constant N, approximately follows normal distribution with mean of P and standard deviation of square root of P times Q over N. So with this distribution results, based on this sample distribution of P hat, we can develop the interval estimate of P and hypothesis test for P. We'll do that in the next couple of slides. The success probability P can be estimated by its point estimate P hat, which is X divided by N. Also, we can estimate this probability using confidence interval. With a similar theoretical development in the basic statistics class, the confidence interval for P is point estimate P hat plus minus table value, and then the standard error of P hat. So here, the standard error of P hat is right there. So you can just plug in those numbers there. Thus, the confidence interval for P is P hat plus minus Z alpha over 2, square root of P hat times 1 minus P hat over N. In the octopus example, we can conclude this confidence interval by plugging P hat, N, and Z table score. Of course, in the later slide, we'll do the same thing using the software. But you can see how you can actually calculate this by hand as well. Briefly in this slide, we can see the hypothesis test for one sample proportion P. The Z-test statistics can be calculated using P hat and P naught, and then N, the sample size. When making a decision, we can use either critical values here, Z alpha, negative Z alpha over 2, or p-value based on Z table. Okay. In step 3 and 4, we'll give you the exactly same conclusion as long as you're using same significance level alpha. In general, we'll use statistical software and obtain the test statistics and p-value. Then using p-value, we'll make our decision comparing it to the significance level alpha. Note that when the sample size is small, the normal approximation may not work, which means the confidence interval and hypothesis test based on Z, standard normal distribution, won't be appropriate. In this case, an alternative test, binomial test, can be used. Binomial test will be discussed in Module 7, non-parametric analysis. Okay. Both confidence interval and hypothesis test for one sample proportion can be done using prop.test function in R. The first number is X. So this 12 is X. And then the second number is N, 14. And then we are comparing our P is equal to 0.5. So our P naught is 0.5. And we are doing alternative hypothesis as greater. If you don't specify P and alternative, you will actually assume P is equal to 0.5, and then your alternative is actually two-sided. So this one, the second one is actually two-sided test, and this one, the first one, is one-sided test. The results are shown in a gray box. The 95% confidence interval can be found when we put alternative as two-sided. And the gray box on the right-hand side is the results of that. Thus, we can say that these are the confidence interval, 95% confidence interval. So we are 95% confident that the true success rate that Paul correctly guesses, the winner is between 0.5615 and 0.9749. The result of one-sided test with alternative as greater is on the gray box on the left-hand side. The p-value is 0.0081, which is smaller than alpha 0.5. And we can conclude that we have statistically significant evidence to say that the true success rate is larger than 0.5. P-value of 0.0081 is a small p-value, and we say it is very unusual to detect p-hat as 0.857. Is the true p-value is when the true p-value is 0.5. Thus, we can say that success rate is significantly larger than 0.5 random chance. So we're not quite sure if this implies psychic power or not of Paul the octopus, but surely it is unusually high successful rate. That's probably why the Paul got really famous.